Here we go, exponential and logarithmic applications. We're going to be writing an exponential equation, moving off to a logarithmic equation in the end, and using them to solve some problems. In 1999, the population of the country was 70 million and growing at a rate of 1.9% per year. We're going to assume that the percentage of growth rate remains constant, and we're going to express the population P of this country as a function of time, the number of years after 1999. So let's go ahead and look real quickly. We're going to write down the idea of what an exponential function is, y equals ab to the x. As a reminder, a is going to be our initial, and then b is going to be our rate. And in this case, we are talking about a growth rate, okay? And anytime we want an exponential rate, an exponential equation to grow, we need to think about the idea that we should have 1 plus our rate. And in this case, our rate is 1.9%. So R equals 1.9%. We're going to start by taking that 1.9% to make it applicable to our problem. We are going to move it in and change it to a decimal. So we get 0.019. And so when we calculate our growth rate to put in our exponential equation, it's going to be 1 plus 0.019. Okay. Now we can go ahead and write our function. We do need to write it as P as a function of T. So we are going to do that right now. I'm going to write P of T. The population is a function of time, equals to our initial value. Our initial value was 70 million, says it right there. And now our growth is 1 plus 0.019 or 1.019 to the T power. Now we need to pay attention the entire time that this represents population and this represents time, okay, from 1999, okay? When we move on into the next problem, it says, what is the population of the country in 2050, okay? And so our time is 2050, but what T means is T represents from 1999. And so we need to find the years, how many years have passed. So we're going to say T is going to be equal to 2050 minus 1999. And that comes out to be 51 years. Okay. And so nice and easy, we just come over, we find P of 50 equals to 70 times 1.019 to the 51 to the 51st power. Let's go to Desmos. We'll make some calculations real quick, and let's plug our P of T equation. Now, Desmos doesn't like P of T so much as it likes P of X. So I'm going to write P of X equals to 70 times 1.019 to the X power. And we can calculate this nice and easy by saying P of 51. And it'll give us the value of 182, or I can actually just type in X equals to 51, and I can look for that intersection, and you'll notice that an intersection says 182. So we're going to come back to the class kick, and we're going to say, okay, that means that P of 51 is equal to 182.8 million. I'm going to make sure I post my units on this. So P of 51 years is 182. That's how much would be there in 2050. Now, if we continue, it says, what function can be used to model time in years as a function of population? So we started with population as a function of time is what our equation is telling us. But we want to switch the order, okay? We want to switch the order. We want time as a function of population. So really what we're looking for is T of P, which means we're switching the X and the Y values. And when we do this, that means we're finding the inverse, okay? So I'm going to write that right here. Let's write inverse, find inverse. And when we find the inverse of an exponential, that means we're going to be using the logarithm. And remember, that's log base value equals expo. So let's go ahead and do that. I'm going to go ahead and change the lettering out to make this life a little bit easier. So y equals 70, 1.019 to the x. I flip things around. And before we can go to our logarithm, we need to divide by 70. And we are going to get y over 70 equals to 1.019 to the x. Now, check it out. We have, luckily, this is going to be our value. We have just a base, a value, and an expo. So at this point, we can go and write our logarithm. I'm going to write that right over here. I'm going to say log base 1.019 y over 70 equals to x. Now, the one thing we have to remember is we switched our x and our y's. So our function really is P inverse of t equals to log 1.019, and then we have t over 70. Now, this, because we've switched it and it's the inverse, this represents time, because it's opposite now. And this right here is going to represent our population, okay? Because we have a completely different formula. Let's go over to Desmos. We're going to check that our inverse is correct and that our time formula is correct, our time equation is correct. So I'm going to come over here and I am going to put, let's call it t of x. Remember, Desmos does not like having an inverse, so I'll just call it t of x equals to log. We're going to come down here. We're going to put in our log value. Miscellaneous, I'm going to come over to log, put in my base 1.019, and then I'm going to put x divided by 70. Now, in order to check to make sure that our inverse is correct, and we always need to do this, I always put my line y equals to x to make sure it's a reflection, and it looks like a really nice reflection right now, okay? And then I go ahead and I just do the composition of the two functions, so p of x and t of x. So I'm going to put p of t of x, and notice that the line y equals to x lines up, so they are in fact inverses, and we have in fact done this correct. Now I can go ahead, now that that is verified, I'm going to go and answer the question. And it said, the next question, it says, what year will it be when the population reaches 107 million? So the population is 107 million. Well, if I use our inverse equation, if I use the inverse equation, t over 70, this is the population. That is the x value of that equation. So what I want to do is I want to find out when t is equal to 107, or on Desmos, x is equal to 107. So I'm going to come over here, type x equals 107, okay? And I come over and I find out where that is on my logarithmic function. And at 107, that is 22.54 years, okay? So that happens at 22.54 years. So P inverse of 107 is 22.54 years. And that is from 1999, right? So from 1999 plus 22.54 years is going to bring us to 2021.54 is the year. So 2021 is that time period. We can also, if we needed to, do this by verifying it in the other direction by saying, okay, we can say, let's find t of 107, and that would also verify that work.